Okay. So can you see my screen? I think you can see my screen. Can you see the blackboard?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Wait, people are waiting in the lobby. Let me accept. Good. Okay. So here we go. So the first question that we ponder about is what is learning? So if you think carefully that till now what you have done is you have tried to solve a problem. So when I say I will try to solve a problem, then there is something which is called as input to the problem. And depending on that, you want to make out something which we call as the output of the problem. And when you solve a problem, what is your primary objective is to find the solution which can translate any input to its desired output. So therefore, any problem that we think in this world are of this nature, that I have a set of inputs, I need to do something over those set of inputs to produce my desired outputs. Now think carefully that till now, whatever you have seen about this particular solution or the function that solves that, you know that it has a closed form, either in mathematical or in a programming sense, because either you can iterate over the input and can produce the desired output. So in general, I will say I know what the solution is, and I can mathematically pin down the solution. That is very important, that I can mathematically pin down the solution till now. Therefore, I go for writing codes for it and do it. However, so these kind of things, when we mathematically can pin down, what we do is that we write a program which can take arbitrary inputs and can produce desired outputs. So these are all the categories that I am mentioning here. So a problem, I solve it by mathematically pinning down its closed form or a known form, which can deterministically tell the output given the inputs, and I can do it. However, there are a set of problems if you do not know how to mathematically pin down. I will give you an example soon. So these set of problems are the problems of our concern in the whole course that we are going to learn. So that means that I do not know the exact way of solving for every inputs. And I do not know also all the varieties of the inputs that I will get to solve the problem. So therefore, what I have to do is that think now how humans come and learn, how a little boy or a girl start learning the color. You go and teach him something that this is red, this is yellow, this is blue. One day he tells everything wrong initially, and suddenly he corrects one, two things, and suddenly he makes every color right. So that means something which we call as experience or training that is essential to solve those problems which we do not know a mathematical answer. So therefore now someone has to iterate over this experience and training in human brain, or some kind of a model needs to iterate over this experience training one by one. I give one example, second example, third example, and so on. And I go on iterating and finally coming up with a generalized solution of the understanding of the problem. So this is the part that we call it as a machine learning, where your learned solution is this one. So it means that I had a set of training examples to train some through some algorithm, I get this training in such a way that I finally come up with a model of the program itself, not directly doing the program as in other sense, but I come up with certain algorithmic way of the program. So this is my output of the learning. So this program is now capable of taking X and producing desired Y. So this is the fundamental part from where we are trying to deviate from deterministic solution of a problem towards learned solution of a problem. And that is what we mean by learning. Immediately the question comes, when can we learn? Immediately the question comes that when can we learn? One, you have already know the one point that when mathematical pin down is impossible. For example, you try to recognize face. So while recognizing face, you cannot mathematically pin down because everyone's face has certain other features. Recognizing fingerprints for authentication, some features are different. However, what gives us the motivation to go for learning is the most interesting part, that a pattern exists. See, when I say that something, when I give you the example that a small kid is learning the color of particular objects, some pattern exists which dictates the color. Someone is trying to recognize the face, some pattern exists because between eye, within a certain distance below that, nose will start. So when can we learn? This is one aspect that we should think of, noting the problem and trying to learn for it. This is the second aspect we need to consider, that whatever we are trying as a problem to learn, is there a pattern? For example, you cannot learn if my output Y is a random number generating output, because there is no pattern in that case. It does not depends on X. So those kinds of problems you cannot learn. So these two are very essential when we can learn. And the third part, which is the necessary part, is that you must have data. Data exists for training. So if this does not exist, you cannot learn, because our primary assumption of learning is to have this loop in an algorithm to come out with this output model, which is an abstraction of the solution, not the exact solution as you do in case of deterministic program writing, but an abstraction of a solution which can produce desired output given the desired inputs. So if any problem, any company comes up and tells you, I will give you $1 million, first you have to build a model which can learn for certain to do some task. First you ask, how much data do you have? If you don't have data, forget about learning. So this is very interesting observations, that these three are the position where we need to learn things. Okay, any questions do you have till this point? Okay, let me proceed a bit. So now, if you think very carefully that what happens if I relax each of these assumptions? So if data doesn't exist, forget about learning. So I cannot relax this assumption. This is absolutely required to have any design to have any model to learn. We need data. That's what we is our assumption. But let's say if there is no pattern, then what will happen? Can I do not write an algo so that it could learn? So this is a very interesting observation, that if no pattern exists, so by no pattern, I am not saying it's totally random, but it's a wide variety and it's not, you cannot put down in terms of a pattern, then also your machine learning will work. But later we will see theoretically it will not work as good as we believe to be. Because as you can see that you do not have any basis to formulate your model. So it may work a little bit vague way than you have thought. So even if no pattern exists, you can apply your machine learning algorithms or machine learning solutions to build up a model, but it do not work as expected. Secondly, can we do machine learning for the deterministic problems as well? When mathematically we can pin down, let's say, can we do machine learning to know a number is prime or not? Given a number n, can we do machine learning for a number prime or not? I have let's say thousands of such examples. I give you that 2 is prime, 3 is prime, 11 is prime. These are my test examples. You will see that in case where we have a deterministic solution, we can apply machine learning, but that is not the goal of machine learning, and the benefit of machine learning is not established by that. Eventually, due to these experiences being gathered in the model, you can somehow classify which is prime and which is not prime. That's not the problem. But when mathematically pin down is possible, it is not the tool that you will use for machine learning. So machine learning is not for those that you know that I can mathematically solve the problem elegantly. So machine learning is for those problems where mathematical pinning down is impossible to look into. So when I pointed out that what is actually learning means, so I can theoretically now say that learning is a technique by which from experience I build up a model to solve a task, and iterating over this experience on the model, my performance keep on increasing. Okay, so machine learning is a procedure through which from the experience or the training, you can build up a model or an abstraction of a solution to solve a task. With higher experience, the performance over solving a task improves. This is how the traditional definition of machine learning goes. And when we say that performance improves, later we will try to note down that what are the formal definition of performance and how it is being improved. When we say solving a task, what do we mean by solving a task or making an error in that? So gradually in this course, we will theoretically see that what does this definition theoretically leads to. Before that, let me share with you a little bit of examples of machine learning problems. So one of the classic examples is credit approval. So what happens is that someone's profile comes in, let's say age 23 years. How many years he is doing the job? Let's say 1 year. What is his salary? Let's say it's 10 lakh per annum. Does he have any debt with his name? Let's say he has 1 lakh debt from bank. So years of residence. Let's say he has 2 years of residence where he's. So these are the inputs depending on which you need to classify whether you will approve him for a loan or credit or you will decline. Now try to see that is this problem is the actual problem to learn? Yes, because I can have some set of data in my hand. As I said, unless the data, I cannot do anything. I have data because I have prior customers whom I have learned for approval or denial of loans or credits. Now, this I could not mathematically pin down for certain kind of that if his age is this much or salary is this much, I will approve or not. I could not mathematically pin down because case to case basis it may vary, and the number of attributes, so we call each of these as attributes, can be huge. So we cannot mathematically pin it down. But there must exist a pattern, because depending on certain values of this, with some parameters, if I try to plug in here and then let's say I add it or do some mathematical jugglery, if it goes beyond threshold, I can approve or not. So I can find out certain patterns over it. So this is a good problem that I could apply machine learning over it. And as you see that I want a decision to be 1 or decline -1. So we call such kind of a problem as classification problems. So depending on the input attributes and its value, I want to classify whether I will pass it or fail it. So here, as you can see, your X is the attribute set. So your attribute set X1, which is age, X2, which is job, and so on. But your Y is nothing but, or I would say that it is +1 or -1, either accept or denied. So these kind of problems in machine learning domain, we also call it as classification problems. The second example I could take is a very famous example. Many of you have know that it's Netflix movie rating example. It has been a 10-year standing problem where Netflix asked for a 10% improvement in its prediction of rating. So some movie comes out and people have to predict that what is the rating of that movie going to be. And Netflix says that if somebody can predict in such a way that the existing algorithms they do, let's say they predict the rating and they could get a 10% improvement in the prediction depending on the closeness of actual rating. So they will give a $1 million of prize. So, and it took 10 years to get into 10% improvement in the rating. But if you carefully look into this problem, let us see the features of this problem. Suppose you have a movie. So a movie is basically has a set of attributes in it. For example, a movie may be a comedy. So let's say it's a comedy content is too much. Maybe if it is a comedy movie, let's say it has a action content very less. Then it has, let's say, in a comedy, I mean, in a comedy movie, and let's say it's the movie language of the movie. Let's say the movie language is English, the kind of a language which is accepted. That language being accepted by a broad customer. So these are what I want to mean is that every movie has certain features that whether it's a comedy, whether it has actions, even you can see that there are features like whether Shah Rukh Khan is participating in the movie or not. How much screen presence does Shah Rukh Khan has, depending on the duration of the movie. So let's say Shah Rukh Khan has half of the screen presence, like that. And if you try to think about the user who rates the movie, he also has certain parameters to think for rating the movie. For example, I would say that user likes comedy very little. If some user likes comedy very little, so this is, does he like comedy or not? If some user likes action, so some user may like action more rather than comedy. So this is like action. So what I want to mean here is that this is the attributes of the movie and this is the attributes of the user. And if you try to see the Netflix rating problem, what you are trying to do is that you are trying to correlate between them to find out your ultimate goal, which is the rating of the movie. Here you see, unlike the classification problem, it is not approve or decline. Rather, you are trying to predict, let's say IMDb 8.5 out of 10. You're trying to predict a rating value. So first of all, we call such problems as regression problems. So in classification problems and regression problems, the main difference is that instead of a yes no answer we want as an output, we want a value a value-based answer in the output. That is the only difference between the name nomenclature of these two problems. Now, looking at these problems, you can easily understand that there is certain dependency that for the classification credit approval problems, what happens? There is an attribute feature space. For example, the attribute x1 and x2, if I only have two attributes, so depending on this feature space, something is classified as good, we can approve, and some of them are classified as bad, we can reject. Now, your job as a learner is to take one by one examples and try to classify a boundary. You will say here they are good, here they are bad. Now, what you will do in your learning algorithm, that you may start with this kind of a boundary where you are misclassifying something, then you gradually try to switch it this line over up and down, or maybe rotate this line accordingly with its slope, and try to come up with a fitting line which can classify correctly your training examples. That is what your learning algorithm do for this classification examples. Regression examples, what you are trying to do is that if I have these two features, rather I have shown here many features of the movie as well as user. Let's say if I have two features, x1 and x2, the regression try to do that you have some prior knowledge about the value that it will take in the third dimension. So I have this. Let's say there is a third dimension. I have a certain value. I can have values of that. Now you are trying to fit some kind of a curve in between those values so that whenever you want to judge a new value with the value of x1 and x2, you can judge that what the rating value would be. That's kind of a regression problem that we want to solve. Unlike classification, where only you need to cut the positive and the negative training examples to decide upon that you are doing it correctly or you are declining it correctly. Regression is you need to fit something so that with the value of x1 and x2 in the third dimension, if it is my y, I can take out and say that what is the value of y. So these are all parts of learning algorithms that we will discuss throughout this course. Okay. So these are very interesting two problems. The third kind of problems that we are considered is, see that we want to learn the function which takes a set of inputs and produces a set of outputs. So effectively, you see that there could be some problems. You see in the Amazon that when you buy something, they give you certain recommendations. So there are some kind of problems which is called the recommendation problems. That suppose you have bought the ML book by Tom Mitchell, they give you certain recommendations that you also buy Duda Hart, you also buy the other book by, let's say, some XYZ, you also buy this book by ABC and all that. So this problem is kind of association with your existing with the option that you bought and the other options that I have. So effectively solving this problem, the other way you could look into is that what is the probability of Y being Duda Hart given that the set of attributes through which I bought an ML book. So this is the other answer that you also might look for. So this we call the problems we call associations. And this is also a machine learning problem because you know that these attributes had resulted you to buy a book of Tom Mitchell. Now, what is the probability of such an attribute which through which you bought a Tom Mitchell will also allow you a higher probability to buy Duda Hart? So all these suggestions that you see in this recommendation kind of a thing in any online sites are the top list probability values through which is being associated with your existing buying option. So, and the most interesting example of this kind of probabilistic associations is spam filtering. So when you get a mail, you will see that if the mail contains that you win dollar this, or how are you? Let us talk. I hope all of you have received such kind of a spam mails. So see, depending on the associations of such kind of words and their relative positioning, you judge whether your mail is a spam given that such kind of words and associations, probability of spam equal to 1 and spam equal to 0 given that such associations. So this is another kind of looking into the same problem, but in a different angle. Rather than classify and produce an output or regrets and find a value, we also can see it as a probabilistically, this is more towards looking at a spam. So when your Gmail considers something as a spam, it sees that whether this value is more than 0.8, then it considers it as a spam or not. It is a classification problem, of course, but the classification decision is more governed from the probability analysis of it. The posterior probability, we call it, that what is supposed to happen given such associations are there in the inputs. So with that, three examples, which is of three varieties, you can see that the scope of machine learning is enormous. And if you try to think of such kind of a problem, you can immediately figure out which can be learnable and accordingly try to learn how I can use a model to learn the problem. And with that, you can also see if you go back and see this classification and regression example. So let me tell you more about that. The fourth thing when we do the example, that how to learn automatically. So now let's again go back to our classification examples that we are doing. So suppose we have this data and this kind of a thing. Now how to learn, you can see that you have certain attributes, that x1, x2, x3. So we are only doing with two attributes. So let's forget about x3. Let us say two attributes I have, and depending on that I want to classify. So you can easily see that to classify in this two dimension, I need to put a line. So I can put a line this way, which is misclassifying some of the points like this. I can put a line this way, which is misclassifying some of the points like this. So therefore, it's just in two dimensions. I want to put a line to classify. In higher dimension, it will be called as hyperplanes. But since in two dimensions, you know that equation of a line in two dimension is nothing but w1 x1 plus w2 x2 equal to some constant. That is just the equation of a line. Now the question is how we learn such kind of a classified line. You have these handles. If you change these three handles, your line may be different, right? If you change these three handles, your line can be this way, line can be this way, or line can be what actually you deserved in this way, right? So that is what we call this as the weights. This W1, W2, even this C if I make it as W0. So what our learning algorithm tries to do, learning algorithm tries to change each of these weights with its earlier value plus let's say some delta update on this weight, and keep on modifying this weight iteration wise unless you come up with a line like this that I am shading in to actually classify all your training data. So that is the purpose of your learning algorithm. Regression, you will try in regression if you go by these two features. In regression also, there will be you will try to fit in something which minimizes the error with your training. And so the error is how much you deviate from your training data, and your line should properly fit within it. Though there are ramifications in this fitting, I am not going in the first class with that details, but how properly we can fit, and depending on the good we fit, a new example can be better given the value as a better solution. So this is what we do in regression and this is what we do in classification. So effectively, it is just learning of certain kind of mathematical model. Here the model is just of a line and in hyperplane for higher dimension. Here is just a curve that we want to fit in, okay, or maybe a kind of a, again, a hyperplane, but not it will not be a plane, but it will be a surface. We can say it in regression multiple dimension. I would like to run a hypersurface which will fit those points. Okay. So with that, let me just come into the ingredients of learning or the learning schematic diagram. So we started off with, we want to learn a function like this, which is unknown. This is unknown target that we want to learn. But what we have in our hand from this target is the training data we have. That means we have x1, I know the value y1, for x2, I know the value y2, and so on. So these are the training data that I have in my hand. Now what I am trying to do, I am trying to write my learning algorithm. This is our job, which takes the training data and tries to find out a function which approximately going to relate f, and we call this as my hypothesis. Right? That is what we are trying to come out with, the adjustment of the W1, W2 values and everything. Just one component that I would like to add on is I will try to choose this function that I finally make it as an output from an hypothesis set H. So it has many hypotheses. I am choosing one of them for the output. Now, you might wonder that why I need to choose a hypothesis set rather than I could give it as a free and infinite thing to choose from. See, there is no downside of it. Even if you want to do it from any kind of a model, you can do it by putting this number of hypothesis set is enormously huge. But there is an upside because when we go for theoretical learning aspects and try to prove certain things, then we will find that this limitations of the hypothesis set from which we can choose our answer. So G will be nothing but some HIs. G is some HI. Choosing from this set will give us certain kind of bounds about the learnability aspect as well. Secondly, this hypothesis set is also governed from the domain knowledge. So see, absolutely, if you do not know anything about the problem, it is very difficult to pinpoint a solution so that it could be applied widely. So this is particularly a domain knowledge that comes in. So to give you an example, think about the credit approval. So the problem of credit approval comes here. Your training data is the past customer record. Your learning algorithm is some kind of adjustments of the weight. I just call it as weight adjustment algorithm, finding the hyperplane. What is your hypothesis set? Your hypothesis set is basically what you finally want to learn. This is the topic of what we want to learn. That my hypothesis set could be, I could learn a decision tree, I could learn a support vector machine, I could learn a neural network, and blah, blah, blah. So this means that your hypothesis is a decision tree or a support vector machine or a neural network. And what is that? And depending on the parameters of this decision tree, I could have HDT1, HDT2, all of them as part of my hypothesis set. And among them, I choose G. Let me this G be a neural network NHNet I. I choose something from here and produce an output. So this will be our learning diagram, and we will gradually with this course go on refining it and adding new component to it. So we call it as a learning diagram. Whatever we discuss will fit in here. Okay. So now you can see that I can classify, I can categorize what kind of learning depending on what is the type of training data you have. So suppose I am given an input and output to train. Suppose there is a good teacher who tells you the input as well as the output, input and output, correct output. So when you are given with input, correct output, this pair as a training, you call it as a supervised learning because there is some supervisor who is giving you input and correct output, and gradually you are trying to do your model. So this is supervised learning. Secondly, if I do not give you what are the outputs, for example, just think about this figure. Suppose I have in the y axis the weight of my coins, I have in the x axis the size of my coins. Now you know that 10 rupee coin, the size is also more, weight is also more, so the 10 rupee coin will be like this. Now 5 rupee coin, size is less, weight is a little bit more, so the 5 rupee coin may be positioned here in this place. 1 rupee coin, maybe the size is the same as the 5 rupee coin, but the weight is very less, so maybe the 1 rupee coin will be positioning here. Okay. So now if I give you this data, supervised means I tell you that some of them are 10 rupees, some of them are 5 rupees, some of them are 1 rupee, and then you can easily categorize it in this way. Now if I do not tell you what is this, then your data looks in these two particular attributes. One is size and one is weight of the coins. Your data just looks something here, something like this here, and something like this here. Now see here, I purposefully do not making any supervised impact on what is what. Then what we call as unsupervised learning. We will also learn this, that we will try to find out clusters here. And as you can see, there is no supervisions involved here. You can also find out this as a 2 cluster instead of 3 being the actual answer, because you do not know this is 1 or 5. Or you may also think about that this is one cluster. You may also split it into multiple clusters. The number of clusters is not in your hand because you do not know that what you are going to make out of it. Just you are given certain kind of a data in a 2-dimensional plot and you need to categorize. So this kind of learning, we call it as unsupervised, where I was given the input but not the output. And you have to make a decision of grouping them. The third category is what when we give input, some output we give, not the full output, and we also have a reward with that. For example, think that suppose a child is reaching his hand in front of a hot cup and then he touches and then just pulls back his hand. The reward is negative. So after one time he will not try, second time he again someday tries, and then he or she figures out that maybe the smoke coming out of the cup has a very bad thing to touch. So such kind of a thing, we call it reinforcement learning, that you reinforce your decision making again and again depending on the sum output and the reward thing. Depending on the input, you reinforce your decision making by. And there are many such applications of such kind of reinforcement learning. One of the beautiful applications, the game, in game playing, all this AlphaGo, this chess playing uses this particular thing. Even AlphaGo beats the highest 9 Dan players and all. Similarly, you will be amazed to know the backgammon is a game widely played. The champion is a neural net. So this is where we went in learning that we can do anything using learning. In fact, we can bring out the champions and destroy the existing manual champions. So this is the scope that where we want to we will roam around. So if I recapitulate, we started off with what is learning, the problems that we cannot mathematically pin down, pattern exists, data definitely has to exist. Then we say that there are problems which are called classification problems. There are problems which are called regression problems. So both are just a slight difference about the output that we are going to make. There are problems which are association problems where we need a little bit of probabilistic associations, posterior associations with the output and determine the model. Depending on that, we classified our we characterize our learning diagram that we have the training data in hand. We try to have certain domain knowledge about what we want to build and come up with a hypothesis that almost fits our actual unknown target function. Your f is unknown, g is your output of the machine learning algorithm. So the course will try to deal with how do you learn and what is the guarantee that you get theoretically in learning. And finally, what we have seen, there are types of learning. One is supervised learning, where every time you have input and correct output, just like the credit approval thing and all that. In unsupervised learning, you have input, but you have no output, so you need to only group cluster them. So most of the algorithms of this will be called as clustering algorithms. And you have a reinforcement learning, is which we have some outputs and with the reward. So with that, we almost end in time, but I would like to give you a puzzle to finish it off because that will be the prelude of the next class. So just see this one. So these are your training examples. Okay, I train it within these examples and make that my output will be +1 or -1. Now, in the actual scenario, when the test comes, I give you an example. So what do you think your F would be? Okay, this is the practical scenario, right? What you are trained, you will not get that example. But inherent to that, why I give you this example, if you think carefully that it depends upon what you want to look for. See, if I want to look for this cell, so here you see here everything this cell is 1, then I will classify it as f equal to +1. If I want to look for symmetry, this is symmetric, I will classify it f equal to -1. So with all the lectures about learning and all the vibes about learning, I put you forward in a court-like situation that this example is an example to ponder that can we really learn? So from here, I will like to stop and continue in the next class. If you have questions, I can take some questions right now. You get my point, right? You get a training set of examples, which is classified as +1 and -1. I gave you a new test example. You can see I can classify it +1, I can classify it -1, anything I can do, right? If I see the, I mean, if I in some other order, if I try to see, I can classify it in something or the other. So then the vital question we need to answer is that what is the guarantee that we are learning, or can we really? That is the feasibility of learning, from which we will start our next class. Yeah, questions. Yeah, Prashant.
Sir, where the slides will be available in the
Web
website or
page,
in Moodle?
web page, web page.
Okay.
Sagar. Yeah, Sagar. You're muted, Sagar.
Hello, sir.
Yeah, tell.
Sir, we have heard of credit score for loan approval.
Mm-hmm.
So the
That
credit score is a machine learning solution or it is a deterministic mathematical solution?
no, I mean it depends on the problem statement, but as far as your, I mean, the credit score that you are mentioning, it's a machine learning solution. So credit score means that the score depending on which you will get the next credit or the loan from the bank. It's a machine learning solution mostly.
Okay, sir. Thank you, sir.
Avilash.
So in reinforcement learning, so like you
Hmm.
said, there's a reward given. Like
Yes,
if
yes,
something wrong is done, so negative reward, and if
yes.
it's positive, then something good is done.
Hmm.
So can the reward be considered as an output, and the whole reinforcement learning can be considered as supervised learning?
Okay, so very good question. So actually, you can see that all this, I mean, the supervised, unsupervised, and reinforcement, I can transform one point to another, as just you have said that reward is +1 and -1 depending on that. But sometimes what happens, mostly in game playing scenario, if you see, the reward is not immediately visible, right? That's why I say some output, that you know that in chess that line may possibly cause you harm, but unless you can do it few depth, you are not sure of the reward. Okay,
Uh,
so that's why it is a little different, but in a generic sense, if you tell, yes, I can convert the reinforcement learning problem to a supervised one because of the reward. If I say +1 -1 like that.
okay. And sir, in the unsupervised learning,
Mm-hmm.
sir, what after, sir, if we get the categories, so
Mm-hmm.
what after that? So what will we do with the categories?
Oh, you
Like
no, no.
we are not.
Usually, no. You see, there are problems where categories are important. Who is your friend circles in Facebook? Get it right. So why categories are important? Suppose you have a very close friend circle. So that means your test of buying something will be your friends also will like that product. So how
Okay,
Facebook will give advertisement in their pages? See the problems, right? I do not need what the cluster means. I only need that cluster.
okay, okay, okay.
Yeah, see, I mean, just I mean, I would love to write as a prerequisite of machine learning is just a common sense and intellectual acumen. That's it. That is my prerequisite. As you can see, the last problem that I gave, the puzzle, you ponder about it, that there could be enormous scenarios. We may not have all training data. Then how can we learn? Whether you learn something, I will give you you learn 1,000 examples, I will give you 1,001 example which is bad, which can go wrong. Then what is the
Hmm.
feasibility? So that is the
Yeah.
theoretical part comes in. So I plan this course in such a way that I will give you the insights of it. Not we will tangled in the mathematics, but I will try to give you insights, little bit gradually making you conversant with the mathematical aspects. But I know that you are much more well equipped to learn the mathematics, but the insights that you I would like to push in to this.
Hmm.
Okay. Any other questions?
No, sir.
Good. Anyone else? Okay. So I hope whoever has joined has already taken a note. Can I ask Tarunima to write first? This one, Tarunima, would you be okay if I tell you to write this as a scribe? Tanurima, sorry, Tanurima. I misspelled your name. Yeah, Tanurima, I think you are mute. Okay, okay, okay. Then okay, Tanurima, I will give you later. Tapudduti, can you write it?
Yes, sir, I can.
Yeah. So Tapodduti, for the first scribe, you please write it. At 1 to scribe, I will just direct it in the class. Then maybe this weekend I will float a list.
Okay, sir.
Okay, Tapodduti, you please volunteer this class.
Okay, okay. Thank you, sir. I will do it.
Okay, good. I took your 5-10 minutes extra because we started also late, but I'm sorry for that. Let me stop recording and I hope this will remain.